Well, good morning, everybody. One important announcement as we get started today. I will be away on business portion of next week and then the week following, so we will not meet in person. That's next Wednesday, so we will meet together on Monday, but we will not meet next Wednesday and then the week after that. I guess you get to watch reruns from last year's class because I'll have the videos up and we'll watch those in lieu of class time. You don't have to get up at 7 o'clock to watch the videos at 8 o'clock in the morning. You can watch them whenever you'd like. So that's one advantage of this. And there will be a homework assignment that relates to those items as well. And then, barring unforeseen circumstances, we'll pick up with normal class after the 21st. So I will remind you of this on Monday. I'll certainly probably send out an email and post something in D2L, but do make a note of this. If you show up here at 8 o'clock on February 14th, you will be sitting in an empty room if you can even get in because the door will probably be locked. In our time together today, I want to do a little bit of just kind of practice/review so that we make sure that everybody's on the same page here and we're all understanding the things that we have covered. And then we will continue our discussion on things related to conditional code and presumably get started in our discussion on internal tables. So what I'd like us to do here at the outset is, and hopefully you have paper, something with you can write on. If anybody needs paper, I have some here. But I'd like to give you a few minutes and ask you to do the following. And I'll give you a few minutes to get a head start, and then we will do this together. But I'd like you to, on your piece of paper, write a program that prompts the user for two values. If the sum of those two numbers is even, print even to output. If the sum is odd, print odd. And then after you do the following, or after you do the above, I should say, compare the sum to the following. If the sum is 7, print magic number. If the sum is 14, print double magic. Otherwise, print no magic for you. And I'll just go ahead and give you a hint. One of those requests should be done with an if statement, and the other should be done with a case statement. So you get opportunity to practice that. So this brings together a few things that we've talked about. I'll give you 5 minutes to write that on your paper, and then we'll write it together. You can, of course, reference your notes if you need to, but try and write it without looking at your notes to see how much of what we have covered you remember and are comfortable with. All right, so I gave you this little quick practice request. Let me just mention, we're moving pretty fast, but not too fast, hopefully. And we have looked at some code together. Anytime we cover something and you want to see some code on it and we haven't written code, please do make sure you ask, and we can always pause and work through things together. And periodically we'll kind of pause and do some of these, what I call quick practices here, just as a way of checking up on one another. You will have a homework program. Actually, I could go ahead and mention to you, homework 2 is out in D2L, and it is due, I gave you until Sunday evening this time to complete it, and I believe it calls for you to write 3 different programs that you should be equipped to do really at this moment, although please don't start on it right this moment. At least wait till after class. So the quick practice asked you to do a few things, and I think what we'll do is this: let me just kind of write the program on the screen here, talking through it as we go, and then after I'm done, I'm going to write it one way, and then we'll talk about whether there are any refinements or changes we could make, and then you can ask questions or comment about maybe things that you did differently. So the first thing we have to do is get two values from users. And I will say that it is very common in ABAP to see the first few lines of a program involve getting data from the user. A lot of our programs are interactive, and so we need user input in order to figure out what it is our program should do. So this program will begin like a lot of them do, which is with the keyword parameters, and I need two values from the user. There's no real semantic meaning to these numbers, so it's hard to give them a really good variable name. So I'm just going to call them var A and var B. Now, there is an ambiguity in my specification that you probably made an assumption about, which is reasonable, and that is that we're talking about integer numbers because we're talking about even and odd, although technically it did just say to prompt the user for two values. But so I'm going to go ahead and ask the user for variable A, and then parameters var B, type I, and so I should now have two values from the user that I can use in my program. We have not covered it yet, and it will be a little bit later in the semester before we come back to it, but we don't really have a way to prompt the user with like beginning of program instructions or anything of that sort, because even if I were to, if we look at this here, if I put a write statement here, write hi, okay, and let's save this and activate this and then go get a cup of coffee, and then we can run it. You can see it's going to do the prompting of the values first, even before it writes hi to the screen. And that's just because of the way ABAP structures its control flow. It's going to look for these parameter statements and pull them to the beginning of the chain of execution. So go ahead and put them in that position in your program. But my point is later on I'll show you how we can override that and put like some beginning of program instructions or whatever have you out there. So I've now got my two values from the user, and my quick practice specification says that the sum of those two numbers is even, print even. If the sum is odd, so I need to do some summing of values here, so I'm going to have to store some results. So I'll create a data variable called sum, make it of type I as well, and then set sum equal to var A plus var B. So I now have computed the sum, and the next thing my program asked me to do was if the sum of those two numbers is even, print even. If the sum is odd, print odd. And so I'm going to, at this point, do this. We may, like I said, we're going to come back and maybe make some refinements to this. So I'll create a variable here called result, make it type I as well, and do result equals sum mod 2, because mod 2 will help me determine if this is in fact an even number or an odd number. So now to determine that, I need an if statement. So if result equals 0, what kind of number do we know we have? Even. And else, we know if it's not even, by definition it must be odd. And then I have to remember the and if there. Alright, so I have now taken care of the first portion of this. Presumably we'll have to run test this. And now the next thing was this sequence where I asked you if the sum is 7, print magic number. If sum is 14, print double magic. So this is an excellent scenario for the use of a case statement, because I am repeatedly testing the same data object for different values. So in this case, the variable that I'm evaluating is sum. So I'm going to run sum through a case statement, and the scenario was when the number is 7, then I want to write out on the screen magic number. I don't have any kind of end when statement. I just begin the next when statement when I'm finished with the previous one, and so then I have a when the number's 14, then I want to write out to the screen according to the specification double magic. And then I said if it wasn't either of those, so this is a good case for when others, write no magic for you. And now I am at the end, so I do put in an end case statement. So let me just first of all call attention to the indenting and how it was done here. Everything is indented as we would want it to be. Do take care in your programs to take note of alignment and make it match up with our sample code and what I demonstrate in class. So let's save this and give it a whirl and see if it works, and then we'll talk about some refinements here. So if I put in 4 and 3, I'm going to see that that's an odd number, and that triggered the magic number clause. If I put in 8 and 6, that is even, and it triggers the double magic clause. And if I put in 111 and 14, that is odd and triggers the no magic for you. So at least in terms of the testing I've done to this point, looks like we're pretty good. So let's talk about some refinements here. Some of these are just alternate ways I could have written the code. I could have, for example, made my parameter statement a chained statement, dropped a colon there after the word parameters, put a comma there, and done this. Does not in any way change the execution of my program and would be a perfectly fine variation. I do think we need to compute the sum and store it in a variable because I use it in a couple of different contexts. Most particularly, I use it in line 22 as a part of my case statement. And I really don't want to make the computer do a calculation twice, even though it is a pretty simple calculation. So I think lines 10 and 11 as they sit are pretty good. Now as far as lines 13 and 14, I probably could refine this a little bit. For example, I could rewrite my code such that I change the if statement here to be something like this: if sum mod 2 equals 0, and this is a case where I would really like to see parentheses here just for the sake of clarity in the code, and so I'm going to, for the moment here, just comment these lines out. By the way, let me show you this. There are a lot of neat features in the ABAP editor that you might want to play around with. If I highlight these two lines right here and I right-click, I get a lot of things here in choices, but notice one of them is Format, and I can choose Format, Comment Out Selection, and it'll automatically comment it out. And then I could right-click and choose Format Uncomment Out, and that's really nice if you have 50 lines of code you want to comment out for the sake of testing or whatever. So I have now changed my logic a little bit here. Let's make sure the program still runs as expected in evaluating even versus odd. So 14 and 2, it comes back and says that is even, whereas 14 and 3, reports as odd. So that does work for us. I will tell you that older versions of ABAP, going back about 3 years ago or so, would not have allowed me to do a calculation in an if statement. But current version of ABAP obviously does, as we observe here. Let me also point out the only reason I put those parentheses there was for clarity. Some people that are used to other programming languages that require parentheses around the predicate of an if statement or such sometimes drop parentheses all the time where they're definitely not needed. Don't do that, but definitely do include them here. So that's another refinement we could have made there. Anybody do anything else different that would be a refinement perhaps for the program? This program does have one problem with it. Anybody pick up on what the problem is? It's subtle, but it's something that I want you to definitely start thinking about and your ABAP programming. Anybody know what's wrong with this program? What happens if I run this program? What's that?
It doesn't require me to put 2 variables?
Absolutely. I can just hit execute here, and it prints even, no magic for you, which is not the end of the world. It's not like my program crashed, but that's not what my program said to do. My program didn't say get 2 numbers from the user or not. It says get 2 numbers from the user. So what we really need to do here is add the keyword obligatory to both of these. And that's something that every time I want to get you conditioned to the thought that any time you are writing a parameter statement, you need to go through a mental checklist, and one of those things is this something the user has to give to me? And there will be times when input can be optional. So it's not like every time you're going to put obligatory there. But clearly in this program, obligatory is something that has to be there. So this is another case too where if you will get in the habit of thoroughly run testing your program, then you're going to pick up on these kinds of things. And if you're not thoroughly run testing your program, you might forget this and write a program that in the context of our homework would cost you a few points, but in other contexts would just be an incorrect program. Any questions about any of the things that we did here? All right, so hopefully a useful review for you of some of the things we talked about last time. And like I said, from time to time we will pause and do some of these just as a way of helping you to check in on your ability to write code of the sort that we have talked about so far. All right, so let's get into some new things for today. And so to that end, we are on, make sure I restarted our recording, and I did. Looping. There are a variety of different kinds of looping structures that are supported in programming languages. I don't know if this is something you've talked about in other programming classes or not, so let's talk about it just for a second here. There are 3 different kinds of loops in general in programming. You have what's called definite iteration. The idea behind definite iteration is we're going to loop, and before we even start looping, we know exactly how many times we're going to go around. We know we're going around 100 times. We know we're going around 15 times. We know that before we start looping at all. That's called definite iteration. Another scenario is pre-test iteration. Pre-test iteration, we don't really know how many times we're going to go around, but we make a test, and depending upon the outcome of that test, we execute a block of code, and then we run the test again. And depending upon that outcome, we run a block of code, and we may go around that loop 50 times, 90 times, 7 times, or some other amount. We don't know in advance. Post-test iteration, we execute the body of the loop, and then we test. and the test tells us whether we're going to go around again. Now, of course, note the big difference here is with definite iteration, before we execute the body of the loop even one time, we know how many times we're looping. The other two, we don't. We're looking for a condition to match up with. What's the other big difference between pre-test iteration and post-test iteration?
Well, post-test, you're guaranteed one cycle, right?
Absolutely. Post-test iteration, I know I'm going to do the body of the loop once. The only question is whether I'm going to do it a second, third, fourth, or fifth time. With pre-test iteration, I may never do the body of the loop. If the test is, if this value is less than 100 and it's not less than 100, I just skip over the body of the loop and don't do it any times at all. So those are the three different looping mechanisms that programming languages will support. Some languages give us three different looping mechanisms. Some languages give us less than three, but the way we deploy it in our code, we can create these different scenarios. So let's look at how this works in ABAP. Definite iteration is done with the do statement. And the syntax here is pretty straightforward. Do, and then either a variable or a literal number of times, and then however many times we want to do something, or whatever it is we want to do, and then end do closes out the do loop. So an example of this code would be something like this. Do var a times write high, end do. The nice thing about definite iteration can never go infinite on us. We have to specify a number of times we're going to go around, and we can't put an infinity symbol there. So we know this will never ever go infinite on us. But obviously, in our programs, not always do we know how many times we are going to go around. So we can't use this for every scenario. But when we do have in mind exactly how many iterations are going to be needed, this is exactly what we would employ here. Not much to really say about this other than watch where you put your punctuation at the end of all of the statements here, but a pretty straightforward looping construct. Pre-test iteration. Pre-test iteration uses the while loop. Very similar to other programming languages. Like I mentioned a few moments ago, don't put parentheses where parentheses are not needed if you're used to what other programming languages require. But it's statement while, and then some kind of relational condition that can evaluate to true or false, and then one or more statements that make up the body of the loop, and then the end while statement. Now, this can go infinite, so we got to be careful about that. Don't have to worry about that with the do statement, but we clearly do, no pun intended, have to worry about that with the while statement. So, while var a is less than 10, that's obviously a logical expression that can evaluate to true or false. Var a equals var a times 2, end while. There are a lot of implications in using this loop, such as that whatever this test condition is, in some way is going to be modified in the body of the loop, which is what we see going on here with var a. But pretty straightforward syntax, not that distinct from what you would see in other programming languages. Once again, be careful to take note of the sentence terminating symbols there to make sure your syntax is correct. Then we get to post-test iteration. And this looks different than other programming languages. We start off with just the keyword do on a line by itself, and then one or more statements, and then the loop is going to terminate with an end do. So if we ignore what I have right here in the middle for the moment, this is an infinite loop. do and do is an infinite loop. So what I have to do is put inside of the loop an abort condition or a terminate condition. And of course I could have more than one of these, but in this case we're just showing one. And the way this works is you have an if and then your abort condition, and the body of the abort condition could have other lines of code with it, but it needs to end in an exit statement. An exit is what's going to break us out of this loop. So if I forget this if abort condition, this is absolutely an infinite loop. This is the way we do post-test iteration, because the implication is that this is going to happen right at the end of the loop. But there's no such requirement. You could have an abort condition near the top, then you could have more code, and then you could have another abort condition. Obviously, the logic here can be structured however you actually need it in your programs. So an example of this would be do var a equals var a times 2. And all of these we're assuming var a has already been declared and initialized. If var a is greater than 200, exit, end if, and do. Let me ask you a question. Could this code right here as written ever go infinite?
If var a is 0.
If var a is 0, it's going to go infinite. Or if var a is what? Negative. It's going to go on forever. Okay, so I'll show you in a moment here how to break out of an infinite loop should you ever happen to write one in your programs. But this is where you really have to give thought to different potential states of a data object, because at first glance you might say, well, this right here and really this one right here, those look like they're perfectly fine and aren't going to go infinite. Well, you're making an assumption about var a that may or may not be true, because in both of these scenarios, if var a is 0, we're in trouble. Now up here at the top, if var a is 0, we have no problem there. And by the way, if var a is negative, we can't do something a negative number of times, so we just don't do it at all. Any questions about these? So, we have a loop counter that is built into the system. And we're going back to a data object that we talked about last time, the SY data object. You'll get to work with that in your homework 2 programming assignment that's coming up here. But every time I have a loop in ABAP, I get for free a loop counter that I do not have to create, nor do I have to manage. And it's a system data object called SY-index. So let's just look at that for a second, and also show some other examples of these loops that we have just done here. So give me a moment to clear out my editor here, and let's just do a real simple one here with the first loop. If I do, not dove, do 14 times. We'll just write real simple, right. Now, if I do this, that's probably not going to look like what I want. So we got to remember to put in our good friend the slash there. So do 14 times, write high. You know, this is like one of those really, really basic programs that you write when you're first starting out in programming. And there's high written on the screen 14 times. So this SY index, what's the deal there? Well, notice this. I could do something like this. I'll make this a chain statement. This wouldn't have to be a chain statement, but I'll just do it as such. And then we'll do this. I'll put in the keyword loop, colon. and then we'll write out on the screen sy-index. And so now let's see what actually happens here when we run this particular program. And we get this, okay? Now notice a couple of things. It starts with 1, okay? We're not doing the whole starts with 0 thing. So the first time through the loop, sy-index is set to 1, and you see the logic as you see here. By the way, you see how this is thrown over like it is here? That's because I didn't do anything to control the width of the output here. I could, for example, specify a column number that I wanted that to go into, or more particularly, I might have wanted to come back here and do this. I just point that out because we've talked about it a couple of times, and I want you to... Apparently, when I hit the save button, a lot of times I accidentally hit the exit button instead of save. So I apologize for that detour. But it is very common for us to employ this. So here we see what might be something more consistent with what we were looking for. So the rule of thumb is, if I don't need to create my own loop counter, don't use the system one. And of course this means I can of course do something like this. If sy-index equals 7, write special and if. I can incorporate sy-index into the logic of my program just fine. And so we see that incorporated here for the catching of the 7th loop. Now there will be times in your programs when you may need to create your own loop counter. The loop counter that we get by default always just counts by 1 and counts the number of loops. Sometimes in a loop you need a loop counter, but it counts by 2s, or it counts negatively, or whatever have you. Then you're going to have to create your own programmer-defined loop counter. But if you just need a straight loop counter that tells you what iteration you're on, get in the habit of using sy-index. This also gives us a nice transition into another way we could do this. I could do this. While sy-index is less than 14. All right, so in this situation right here, I am beginning a loop on line 8. So sy-index would be initialized to 1. 1 is less than 14. I have to fix my terminating statement here because it's no longer end do. It's now end while. But we'll save and activate this. And see that in fact this is an acceptable alternate way of accomplishing this. Because my specification was less than 14, I get 13 iterations of the loop and then fall out the 14th time. So you can use sy-index as the control for your loop if that is what you need to accomplish. Now I would point out that in the scenario I just showed you, this to me is definite iteration, which means this should be a do loop. But hypothetically, the right side of this could be a variable. While sy-index is less than maybe a value that I calculated, and so that would vary from program to program, this would then presumably no longer be a definite iteration, although that might not be true, strictly speaking. Questions about this?
With the index, like if you have a loop inside of a loop, does it focus on the loop inside of it?
Yes, you would have shadowed instances that you cannot see. So they would be present. If we illustrate this, pictorially, here's a big loop, and then here's a medium-sized loop and another one in it. Every one of these has their own SY index. So when I'm in this loop, I see this one. But when I get to the end of this and I'm out here in this next loop, it has its own SY index. And all of these are independently maintained, so it's not like you lose one when you go into an inner block, but you can't see the outer ones. And so that's a case where you may have to resort to a user-defined loop counter to give you the visibility of it. Very good question.
Could you not like save the index in like a variable and then use it inside one of the others?
Sure, absolutely. You can do that. The key is just whenever you have a statement like a while statement that initiates the next loop, you've now moved to a new instance of an SY index counter.
And it's going to reset the one inside.
It's not going to, in this scenario right here, the first time I go through, this guy would be set to 1, okay? And then I come down and I get to this guy. This guy gets set to 1. He's still 1, but I can't see him anymore. And then I come down here. This guy gets set to 1. I can't see either of these two. And maybe I iterate here, so this one goes 2, 3, 4, 5. All the while these are still 1. And then I bump out of here, so this guy gets set to 2. And then this one starts over again and goes from 1 to 5 again. All the while this is still 1. So they're all independent of one another, and they work pretty much the way you'd think they would work. Other questions? All right, so I introduced to you, at least on the slide, the exit statement. The exit statement gives me a way to break out of. In this case, I'm showing you it breaking out of the body of a loop. As a point of fact, an exit statement will break me out of any time I'm in a situation where I'm in the, for lack of a better term, the body of something. I could incorporate an exit statement into a while loop. I could also incorporate an exit statement into the body of an if statement, if I were so inclined. If the if statement had 20 lines of code in the conditional part of it, but I wanted to break out midway, I could do that. I actually have 2 different mechanisms for what I'm describing here. The exit statement exits the loop immediately, and I'm done with the loop. I jump to the statement that follows the end of the loop block. The other alternative I have is a continue statement. Continue is going to stop the current iteration and trigger the next iteration to begin at the beginning of that control flow. So we've already seen exit in play. Here's an example of continue, and admittedly this is some pretty arbitrary syntax here. This doesn't really do anything terribly useful. While SY index is less than 10, so the first time through that's going to be set to 1, so I'm going to write 1, or 1 is less than 10, so I'm going to write 1 on the screen. If, that's a typo, please fix that in your notes. That should say if SY-index is less than 3. 1 is less than 3. So continue says jump to the end while statement and go back up to the top. So now SY-index is 2. 2 is less than 10. I'm going to write 2 on the screen. If 2 is less than 3, it is. I see continue. I jump to the end and back up to the top. Now SY-index is 3. So I write 3. Is 3 less than 3? No, it's not. So I no longer take the body of this if loop and I write out after end if. So then I'm going to write out 4 after end if, 5 after end if, and so on. The last thing I will write out is 9 after end if, and then this program or this portion of the program will terminate. Continue is not super commonly used. Exit gets a lot of use in the kind of looping structure we just talked about. Exit can also be used to terminate a program. If you're not in a loop, if you're just in regular control flow, if it hits exit, your program will terminate. So sometimes if you need to terminate a program, that would be a structure you could use to do that, although I'll show you other techniques later on that might be more useful in some circumstances. But continue is something to be familiar with, and there are times when it does come in handy for handling kind of special circumstances. We always want to do this except on the 7th iteration. Well, that being the case, if sy-index equals 7, continue. And so we don't do it on the 7th loop, but we do every other time. I also have the keyword check. Check will restart the next loop iteration or continue if it evaluates to false. While sy-index is less than 10, write sy-index. Check sy-index is less than 3.
No typo.
What?
No typo.
No typo. Yeah, thank you. I don't know why. Normally I do a lot of copying and pasting here, but somehow those got separated. So let's play computer on this and see how it works. So sy-index starts as 1. 1 is less than 10. I write, oh yeah, I did the same, so I did copy and paste. I don't know. I'll have to fix that. So check. Is sy-index less than 3? It is, so I keep going. And I write after check. Now I'm back up the top 2. 2 is less than 10. I write it out on the screen. I check. Is 2 less than 3? I'm good, so I keep going. Next time, 3. 3 is less than 10. I write it on the screen. I check. Is 3 less than 3? It is not. I don't execute the code after the word check. I go back up and look for my next iteration. So check is kind of a guard that says you're only getting past me if the proposition here is true. If the proposition here is false, you're done. So it gives me a way to check the value of a variable, or perhaps I could have multiple check statements to check multiple variables, and the only way I get past them is if a particular condition is true. Once again, not something that you're going to incorporate into perhaps most of your ABAP programs, but a very, very useful technique to incorporate in certain sets of circumstances. Questions about this? All right, well, you will get to practice with these a lot, obviously, as the semester goes on. Since we already did one quick practice, we will probably... any questions about this? My inclination is to, I have another quick practice here, but I think we will skip over it for now. Yes, sir.
Will you see this in the homework?
I think so. I'm trying to remember. I might be wrong about that, but I think you will. Other questions? All right. Something to tell you that I did not tell you before that will become relevant in what we're getting ready to discuss. Remember we talked about structures. We're getting ready to talk about structures again. A structured data type is very, very, it's an example of a complex data type. You would have one data object that would have multiple fields in it. So, hypothetically, this is a single data object, but it has 4 fields. So suppose I create this as This is storing information about a person. And I've called it in my program ADDR1. And this stores 112 Elm Street, Johnson City, Tennessee. Okay? Well, I create another data object called ADDR2. And I want to copy this guy here. Okay? What I cannot do is ADDR2 equals ADDR1. Like this was an integer being copied to an integer, or a float copied to a float, or whatever have you. This is too complex an operation to just throw onto the equal symbol. So how do I do that? Is there a way that I can copy an entire structure in one instruction? And I can. I do that with the move statement. Now I'm going to tell you something that is not on your slide, and then explain to you why I put on your slide what I did. Technically speaking, in what I put here on the whiteboard, I could do this. Move ADDR1 to ADDR2. Notice that's different than what's on the slide. What this is going to do is move. Now, it's the word move, but it's a copy operation. So the original is not in any way going to be affected, but you're going to be copying this so that ADDR2 now has the exact same information in it as ADDR1. But notice what I put on the screen there, and that is an alternate syntax that you should use 100% of the time. So even though what I put here on the whiteboard is syntactically correct and will work in this scenario, you want to get in the habit of always using move corresponding. And let me explain the utility of that. Let's assume, for the sake of argument, that this structure right here, ADDR1, is of type ADDR type. And the field names here are, this is number, street, city, state. Those are the field names. I have another structure. The name of the data object is ADDR2. Its type is advanced address type. It has in it a whole bunch of fields. It has, for the sake of my example, street, city, state, zip, voting district, county, municipality, population, and who knows, a lot more fields. Now, in this situation, if I do move corresponding A1 to A2, it will look for fields whose names match. So it will say number. There's no number over here, throw it away. Street, oh, this is going to go here. City, this is going to go here. State, this is going to go here. And the rest of this is just going to be left blank. Yes, sir.
So say for example, you have those types like that, but for example, the street name was for some reason in one database called ST name. Is there any way that you could designate, like, yeah, copy all of these over, and for this one instance, this is where this needs to go, like a pointer?
There's no way that you can accomplish absolutely what you just said. Let's say, for the sake of argument, that this right here was street_1. So it would not get automatically copied. But what I could do is I could do the move corresponding, just going to abbreviate that, and then I could come back and say ADDR2 dash street underscore 1 equals ADDR1 dash street. I could come back, I'd have to come back and manually clean that up in my code. That would be the only way to accomplish that. This is a really, really powerful resource for us when we start working with databases, which is what we are getting ready to do. Because many times our structures will be related to fields in a database table, and maybe in a particular query, even though my database table has 18 fields, I've only retrieved 7 of them. So I have to be very, very careful when I'm moving that data around to put everything where it belongs. So move corresponding. The great thing about move corresponding is you can never shoot yourself in the foot. If you're moving from 2 identical data types back and forth, it works. If you're moving between 2 different data types, it works. Which is why I just encourage students and ABAP developers just always use move corresponding. There's no compelling reason to ever use just straight old move, and you're opening yourself up to potentially having a syntax error creep into your programs.
So what would happen with just move?
Move would stuff number into street 1, street into city, and potentially make a big old mess.
How did that work with like a HANA system with an in-memory, because they're just pointers? So like how could would it just replace?
In the context of your program, we're assuming A1 and A2 are data objects that you've created in your program.
Okay.
And so whether it's a HANA system or anything else wouldn't really matter in that scenario.
You just
Other questions? All right, so I think now we are ready for, this is when things start getting fun. Our first, I guess, structures are a complex data type. So this is our second complex data type. This is an internal table. An internal table is a collection of data objects of the same type. Rule of thumb, ABAP has no such thing as arrays. But an internal table is a much more sophisticated data structure than a traditional array and can be used in place of an array should you happen to need it. So just like you could have an array of integers, an array of strings, an array of floats, and other programming languages, I could have an internal table of integers, an internal table of floats, an internal table of whatever have you. Not saying that's very common, given the kind of processing that we do in ABAP, but you can do that. The internal table is the ABAP structure for allowing this. So that's my next point. Although this can be based on any data type, the most common internal table definition is based on a structure. So over here a moment ago, I put on the whiteboard our good friend, we'll just stick with ADDR1 because it's smaller and easier for me to draw a picture of. Now, when I wrote this on the screen on the whiteboard pictorially, I illustrated the structure vertically, okay? But I think we all understand I could have illustrated the structure, switch to a better color. I could have illustrated the structure historically and said this was number, this was street, this was city, and this was stick. And I don't think anybody would be confused if I illustrated my data object that's a structure thusly. An internal table says we're not talking about one of these, we're talking about a whole set of these. That's an internal table. So I can make an internal table that would be based on, we don't have an integer, we have a whole set of, and these are intended to be dot, dot, dots, a whole set of integers. So in that respect, this is very, very much like an array. But the really nice thing about it is it's actually a lot easier to work with than arrays for database operations and things of this sort. So I trust you see a very significant parallel here between this picture that I've drawn and a database table. The key is, though, a database table is persistent and in our database. An internal table is a data structure that exists in memory as a part of our program. So just like I create an integer and put something in it, I could create an internal table and put something in it. And in fact, I will very, very commonly do that, of course, in my programs. Similar to a database table in structure and use, but stored in memory for the duration of program execution. So here is what we will find that we will commonly do. I need to do some maintenance on a database table. It's dangerous to go in and start carving on the database table directly. So oftentimes what I will do is I'll go out to the database, pull in some information into an internal table, do whatever it is that I need to do with it in the context of my program, and then put it back in the database when I'm done. So we use internal tables a lot for maintenance type operations. I also may need to write an ABAP program that goes and gets something from the database and does some calculations on it. Maybe for analytical purposes. Maybe we're trying to display a report on the screen. Well, internal tables are going to feature very heavily in that kind of construct because I'm going to go get something from the database and put it in an internal table for the sake of the rest of the logic of my program.
Can you put a lock on it so that if you're manipulating that internal, if you pulled it and you're manipulating it before you put it back, no one else can update it?
You're asking me if I can lock the database?
Or at least what you're pulling?
You can. You can. Now, let me say that that also depends on the architecture of the underlying database. For example, one of the principles of HANA is a lockless database. But if we're not running HANA, we can absolutely lock. And we will talk about, we do that with what's called a lock object. We'll talk about that later in the semester, how you engage and disengage and so on.
So how does HANA deal with version control?
How does HANA deal with version control?
Like if more people are working on the same table at the same time.
This is where, well, you have to realize that the idea is we're going to be hitting the database very, very quickly and getting our work done very, very quickly. So you don't want anybody going out and grabbing something and holding on to a resource for the exact problem you're saying. So we might have to go out to a database, grab stuff, but leave it open, do our work, and then put it back and do this quick enough that we don't have to worry about something being impacted. But what you're talking about gets into a much more advanced element of this than we're ready to talk about right now, but you're thinking along good lines for sure. So let's see what my next point is here. So the nice thing is we're going to see that we have to create an internal table, which we may or may not get to today. But once we create the internal table, interacting with the internal table looks a lot like interacting with the database table. I can update, I can insert, I can delete. So we're going to make heavy use of your remembering of things from your database class, not only in interacting with the database, but in interacting with internal tables. Now, I will say that ABAP can be weird, and if you thought, well, the database commands in ABAP are identical to the internal table commands in ABAP, and they're not. There are a few times when the syntax diverges. But for the most part, you're going to find it not to be too troublesome to keep them distinct. Another great thing about an internal table is the size is dynamic. The number of records is restricted only by the capacity of the system. Now, that doesn't mean that you should be writing select star statements on databases that have millions of records in them and pulling them into your ABAP program. You can do that, but this is going into RAM memory on the application server. So if you are not careful, you can very much slow the performance of your system. And so this is a key element here. You can, in an ABAP program, pull in a database table that has 100 fields and 10,000, 100,000, 500,000 records in it, but you need to give thought to that and what of that data you actually need to do your work. As I've already said, an internal table is very, very useful for temporarily storing data retrieved from a database, putting things, building information that you will be putting into a database, creating output, or preparing data for other use. Hypothetically, for example, I have a database table that stores information about users. And I want people to be able to run a program that will give them a screen with fields on it that they can type their information. Already, I trust you could visualize what that might look like with parameter statements. And so I asked them for their city number, their street, their et cetera, et cetera, et cetera. And I put that into a record, which is then going to go into the database. Well, maybe in my program, I ask them for the information on 3 people or 5 people. Well, I'm going to have to put that into an internal table and then copy that internal table or insert that internal table into the database table. So, although this is not like something we set out to do on purpose, the reality is that once we get past homework number 2, it's pretty likely that most of the programs you will write as the semester goes on will involve internal tables, because we do a lot with database interaction in our ABAP programs. So let's talk a little bit more about internal tables. I have different kinds of internal tables. Data in an internal table can be accessed sequentially. So there's the concept of starting at row or record, whatever term you want to use, index 1, and then traversing to index 2, 3, 4, 5, and so on. Or I can search the table based on fields that are designated as key fields. So let's go back to what I have here on the whiteboard, where I have an address used as the basis of my internal table, and I have fields number, street, city, and state. I cannot search this table for a city that matches Johnson City unless this is designated as a key field. And if it's designated as a key field, then I can search it for a value. Now, let's not let this get mixed up with database keys, where these have to be unique. An internal table key field just means that it is something that makes that field to be searchable. Yes, sir?
It's kind of like the same thing with primary key, like in SQL, like related to it or something like that, but very different from ABAP's perspective.
It's different in that we don't have to have uniqueness,
Yeah.
which immediately is a big difference. So I could, for example, say, I want street and city to be fields that I can search by. So I would just designate them as key fields. Don't have to be unique. The only significance here is I can now, when I'm accessing this, I can search by them. I can also search by index. So I'm saying we could traverse this internal table sequentially. We could traverse this table by saying, show me all of the items where city matches Johnson City. And it'll pull those out as long as that's designated as a key. Or I could say, show me row 37. And that's okay too. I can jump directly to that particular index because we can keep track of row numbers pretty straightforward. I'll give you this last point and then we'll stop for today. This is exactly what I was just saying. Keys can be unique. They can be non-unique. Searching an internal table with non-unique keys may result in more than one record return per search, or may result in just the first match being returned, depending upon my search syntax. So, as has already been discussed, this is distinct from what you see in most database interaction, because in your database class you're used to thinking in terms of unique keys. ABAP throws away the concept of unique keys. We can have non-unique keys, in which case, as I said here, if we designate state to be a key, and we have 50 people that are from Tennessee, if I say, give me the people from Tennessee, depending upon how I ask the question, I'm going to get back 50 matches, or I'm going to get back the first match. Questions?
Whenever you copy one internal table to another one, does it copy the key fields with it as well?
The key, designation of key is done in the data type definition. So we'll see that next time. Okay. All right, well, this is a great place for us to stop. I'll see you folks when we get together next week. Don't forget, you do have homework out there in D2L. Even if you don't work on it today, you might want to look at it today so that if you have questions, you can ask them. If anybody did not sign in, please make sure you grab the sign-in sheet and do that before you head out.
Were you